Today's lesson, 10.1 and 10.2, is on the area of common quadrilaterals and triangles. So we're going to start with the area of parallelograms. We can define what the height is of any sort of polygon, which you'll need for the area. We're going to do the area of triangles. And then we're going to look at area of compound shapes, that is made up of two shapes, or of shaded areas, which can be the difference of multiple shapes. Then we're going to look at the area of trapezoids, and then finally the area of kites and rhombuses. Okay, so by the end of the day you will be able to find the area of all the common quadrilaterals and triangles, squares, rectangles, parallelograms, triangles, compound shapes made up of multiple of those shapes, shaded regions which can be the difference of those, trapezoids, rhombuses, and kites. You'll be able to find the area of all of those by the end of today's lesson. Alright, so we've been talking about area. What is area? Area is the area of a plane figure is the number of square units enclosed by that figure. So in area we measure things in square units like square inches, square meters, square miles, whatever. The base is any one of the sides of a parallelogram, rectangle, or triangle. So any parallelogram, rectangle, or triangle has a base. And let's talk about the height for a second. Okay. The height of any polygon is perpendicular to the line containing the base. So, for example, in this rectangle, there's my base, and it is perpendicular to this red line here, so that red line there is my height. Here is a parallelogram, and again, this blue line is my base, and it's perpendicular to this red line, so that red line is my height. And sometimes the height can actually be outside of a polygon. So for example, in this triangle right here, this is my base, and if I extend the line that contains the base out, I see that this line right here that's red is perpendicular to that line containing the base, and so that line there is the height of my polygon. Now that we know what height is a segment that is perpendicular to the line containing the base. The height equals the length of the altitude. So now let's come up with some formulas for area. The first one we're going to start with, here are the common quadrilaterals that you've seen before. The first one we're going to start with is a square. And the area of a square is simply one of the sides of the square squared. Hence the term squared to begin with. A rectangle, as I'm sure you know, the area is the base times the height. So we can put both of those in our notes to start. So the area of a square is equal to a side squared, and the area of a rectangle is equal to base times the height. Okay. Now we want to talk about the area of a parallelogram. And let me show you that parallelograms actually have the same area as rectangles. So right here we have a parallelogram. And if I take this blue piece here that is part of this parallelogram and I move it over to the right, I turn it into a rectangle. And so if the area of this rectangle is base times height, then this parallelogram, which has the exact same area, just moved around a little bit, must also be base times height. So for all of these here, it is base times height. All parallelograms, the area is base times height. Now a square, base and the height are the same thing, but again, it's still base times height. So the area of a parallelogram on our notes is base times height. And again, there's the height is perpendicular to the base. Okay. Now that we know those formulas, let's do a couple of quick problems to show we know how to use those formulas. So it's asking us in problems 1a and 1b to find the area of a parallelogram. And the area of a parallelogram is base times height. In this first one, I can see that my base is this blue line here, which is 5. And my height is perpendicular to that base. It is 4. Multiplies those together, and I get that this is 20. And again, what units am I using? It's square inches, because this is 4 inches and 5 inches, so it would be 20 square inches. For this 1b, once again I have a base. In this case the base is 2, and the height is the line that is perpendicular to the line containing the base, and that would be in this case 3.5. Multiply those together and I get 7, and the units would be square centimeters. Alright, let's do another problem. It's asking us for this parallelogram ABCD, it's asking us to find DE to the nearest tenth. And it's suggesting that the first step would be to find the area of the parallelogram ABCD and then use that formula again to find DE. Alright, so I can do this because what I know is I can find the area of ABCD. Okay? The area is the base times the height. The base is going to be right here, BC, and the height is the line that's perpendicular to the base. That would be 9. So multiply those together and I get that the area of this parallelogram is 117 square inches. Now that I know that, I can use the formula again. The area of a parallelogram equals base times height. In this case, I know it's 117 equals base times height. Now I'm going to use a different base, the base at the bottom here, which is 9.4 inches. And I'm going to use DE as the height. That's the variable I'm trying to find. So I'm just going to call that H. So if I divide 117 by 9.4, I get that H equals 12.4 inches. So the height would be 12.4. And again, I can either use AB as the base, in which case DE would be the height because it's perpendicular, or the first time I did it, I used BC as the base and FC as the height because it is perpendicular to the line containing the base AD. Alright, so if you understand how to do these problems, you should now pause and go to the first classwork, the area of a parallelogram, and solve those problems, and then come back to your lesson. Now let's talk about the area of a triangle. Any triangle can be duplicated and rotated to make a parallelogram. So here's a triangle. I can take that triangle, make a congruent triangle exactly the same shape and size, can rotate that second triangle 180 degrees, and I make a parallelogram, which we just found out that the area of a parallelogram is base times height. And this particular parallelogram, as we just said, is made up of 2 triangles. So if there are 2 triangles and the area is base times height, and there are 2 of them, then each one must be 1/2 of that. So the area of a triangle is 1/2 the base times height. And so we can use that to think about this particular exercise here. Kai uses geometry software to create the figure at the right. She constructed AB, so AB is the base, and that's not changing, and point C not on AB. She then constructed a line K through that's parallel to AB and through point C. Next, she constructed point D that is also on the line, and as well as AD and BD, and she dragged D back and forth along this line K. So she can drag that point D, you can see the little hand there, and she can drag it all along that line K to C or anywhere beyond. And how does the area change? Explain. Well, the area does not change because the base stays the same at AB, and the height stays the same because, as we learned earlier, the distance between any 2 parallel lines is always congruent. So the height is going to be the same whether she goes to point C, point D, or in fact any point on line K. So anywhere that Kai drags this, she will still have triangle AB, and whatever the third point is will always be the same area. Alright, so let's do our notes. The area of a triangle is 1/2 base times height. And for a triangle, if it's a right triangle, the height is actually one of the sides of the triangle. If it's a acute triangle, then the height is inside the triangle. And if it's an obtuse triangle, then the height is actually outside the triangle. So let's do an example of each. In this right triangle here, I have my base is 7 and my height is 4. So if I multiply those out, I get 1/2 of 28. The area of this right triangle is 14. For an acute triangle, this time my base is 4, and my height is inside the base. It's perpendicular to the base. It is inside the triangle. That is 2. So I multiply 4 times 2, I get 8. 1/2 of that would be 4. And then finally, an obtuse triangle, it's exactly the same thing. To get the area of this triangle, it is simply 1/2 the base times the height. My base is, in this case, 7. My height, in this case, is perpendicular to the base. It is 10. So plug those in. I got 1/2 of 10. I'm sorry, 1/2 of 70. That would be 35. So the area of this obtuse triangle is 35. But the key thing is that the height is always perpendicular to the base, as it is in any polygon. Right. So here's an example problem to try to find the area of this triangle. To do so, again, the formula is 1/2 the base times the height. In this case, my base is 5 on the left and 8 on the right. Put those together, and that's 13. My height is 6. Multiply those together, and I get that that is 1/2 of 13 times 6 is 39 square feet. Right. Here's a mental math problem that if we were in class, I would tell you you have to do 30 seconds to do this problem in your head. So pause this and try it 30 seconds in your head, see if you can do it. Alright, so to solve this, I draw the altitude, and this altitude, because it is an isosceles triangle, breaks up the base into equal sides. So if this is 10, then this is this parallel, and each of these bases is 5, which, as I've told you before, if there's one triangle I want you to memorize, it's a 3, 4, 5 triangle. This triangle is a 3, 4, 5. And so now I can figure out the area of the triangle. The area is 1/2 base times height. That would be 1/2. My base is 10. My height is 4. That's half of 40. That is 20. So again, if you could remember a 3, 4, 5 triangle, you can literally do this problem in your head. Alright, so if you can do area of triangles, then pause this lesson and go and do classwork 10.1.2 on area of triangles, and then come back and we'll talk about area of compound shapes. Okay. So some shapes are made up of multiple other shapes. So for example, in this shape here is made up of a parallelogram that I put in red, and this triangle I've put in blue. So to solve the area, I need to find the area of both of these pieces and then add them together. So to do this red triangle and then this blue triangle, and then I'll add them together. Okay. The area of a parallelogram is base times height. In this case, that is 8 times 10. So that would be 80. So I know that the area of this red piece is 80. But now I have to find the area of this blue. And I see the height there is 9, but I don't see the base. But luckily, I know that in a parallelogram, opposite sides are congruent. So if that side on the left is 8, then that side on the right is 8. Now I have the formula I need for the area of a triangle is 1/2 base times height. So I know that's 1/2 8 times 9, or 1/2 of 72, or 36. So if I add up my 80 and my 36 together, this whole shape together would equal 116 square units. So that's how you do a compound shape. You have to add up two different shapes. Sometimes, however, instead of having to add up shapes, you may have to subtract shapes if you want to try to find the area of a shaded region. And that can be made up of more than one shape, in this case 2 shapes. So you're going to find the area of each shape, and then you would subtract as necessary. So here I have a parallelogram, and there's a right triangle that's in white inside. I want to find out the area of this yellow piece, what's left. So to do that, I'm going to find the area of the parallelogram, which is base times height, which in this case is the base is 20 and the height is 15, so that would be 300. I then need to find the area of the triangle, which is 1/2 of my base. The base would be that bottom piece is 20, but then I'm not taking 6 of it, so it would be 20 minus 6, and the height is the same as the height of the polygon, so that would be 15. So that would be 1/2 of 14 times 15, which is 105. Now, to find the area of the yellow, I'm going to find the area of the parallelogram and then subtract out that white triangle. So I'm going to find the whole parallelogram and then subtract out the white triangle. So in other words, I'm going to take 300 and subtract out 105, and I get 195. So the area of this yellow piece is 195 square units. Okay, so if you feel comfortable in doing compound shapes and shaded regions, you should do classwork 10.1.3, and when you're done, come on back to do the area of trapezoids. Right. So we've talked before about that the area of parallelograms is base times height. The area of trapezoids is very similar. It is the average of the bases times the height. You'll see that both of those trapezoids have a small base and a large base. I take those, I average them together, and then I multiply it by the height. In fact, the average of the bases times the height would work for all parallelograms and trapezoids, except it's just much easier to just remember the base times the height because, of course, the average of the bases of a rectangle, rhombus, parallelogram, or square are just its base because they're both the same thing. Alright, so a trapezoid, reminding you, a trapezoid is a quadrilateral with exactly one set of parallel sides. So it looks like this. The height of a trapezoid is the perpendicular segment from one base to the line containing the other base. So, for example, right there is the height of a trapezoid. That would be an example of a height inside the trapezoid. Sometimes the height is going to be on the trapezoid. If it's a right angled trapezoid, then for example, that is the height because it's perpendicular to the base. And depending on how you have it drawn, it may be the height may be outside because that line, the height is perpendicular to the line containing the base and the bottom. Okay. To find the area of the trapezoid, as we said, it's the average of the bases times the height. The average, to find the average of two numbers, you add them together and divide by 2. So it would be 1/2 times my bases together and times my height. So my formula is 1/2 height times the sum of my bases, base 1 plus base 2. Okay, so let's do an example problem. Find the area of this trapezoid. Well, it's equal to 1/2 the height times the sum of my bases. So I can plug in my values here. That would be 1/2 of 7.5 times 9 plus 22, or 1/2 of 7.5 times 31. Multiply that out, and I get that that's 116.25. All right. In this problem, I need to find the area of the trapezoid, but to do it, I'm first going to have to create a special triangle, a 30, 60, 90 triangle to help me find the altitude because I'm missing the altitude. I'm actually also missing the bottom base. So to do that, first I would draw this line here. That makes this a right angle, and since that other is a 30, this is a 30, 60, 90 triangle. So I need to identify the 30, 60, 90. I'm going to write in my ratios of n root 3, 2n. I'm going to find a side with a value and use it to write an equation. I know that 2n equals 10, so n equals 5. And then I can use that equation to calculate the other necessary sides. So the side across from the 30 degrees, that's going to be my altitude. That's going to be 5. So I can put it in right there. And then the side across from the 60, that's going to be n root 3, which is 5 root 3, which is about 8.66. So I can put that in here. And the reason I need that is because I need to find this piece here, x, which is 14 minus 8.66, which gets me 5.34. And the reason I need that one is because I need the piece that is across from it, because that makes a rectangle over on the right hand side. So if this top piece is 5.34, then the bottom is 5.34. Now I have all the sides necessary to be able to solve as a trapezoid. So then I can find the area. I know it's equal to 1/2 base times height. I'm sorry, 1/2 base. Let's try that again. 1/2 of the height times the average of the bases. The sum of the bases. 1/2 the height times the sum of the bases. So I can plug those values in. 5, 14, 5.35. multiply it out, and I get the area of this trapezoid is 48.35. Alright, so if you feel comfortable about defining the area of trapezoids, click on classwork 10.2.1, and then come back to learn about rhombuses when you're done. Alright, so far we have talked about trapezoids and parallelograms. We've said that all of them, the average of the bases times the height, although the easiest way to do it is the average of the bases times the height for the trapezoid and the base times the height for the parallelogram. The final piece we want to talk about is kites. And for kites, the formula is the area equals 1/2 the product of the diagonals. So 1/2 diagonal 1 times diagonal 2. Since kites are defined as alternate sides are congruent, this formula would also work for other shapes where the alternate sides, where the adjacent sides are congruent. So for example, rhombuses and squares, the formula 1/2 diameter 1 times diameter 2 also works. So let's do an example. First of all, the formula is half the product of the lengths of the diagonals, or as I said, 1/2 diameter 1 times diameter 2. So let's find the area of this kite here. The diameter 1 is going straight up and down. The top piece is 4 and the bottom piece is 11, so that would be 15. Diameter 2 goes across from left to right. That would be 6 and 6. Put that together, that would be 12. The formula for a kite is 1/2 diameter 1 times diameter 2, so that's 1/2 of 15 times 12, which would get me 90 square meters. The second one for this rhombus here, I know that rhombuses are parallelograms and parallelograms are diagonals which cut each other in half. So if that top portion is 25 in the upper right, then the bottom left it must be 25, so that whole diagonal is 50. And the second piece is also cut in half, so 22 and 22 is 44. So the area of a rhombus is 1/2 diagonal 1 times diagonal 2, which is 1/2 of 50 times 44. Multiply that out, and I would get that that's 1100 square feet. Alright, if you feel comfortable knowing how to do area of rhombuses and kites, then you have two different classworks to do, 10.2.2 and 10.2.3 to show mastery of this subject.